Just place it with the thing. I go upstairs.
Bye bye. Hi guys, how are you all after the break? Was the linear programming heavy or you were okay with that? Did you understand and do that? It really helps with algebra too. That's why I gave you 5 problems. Okay, where are we on that alchemist thing in this class? Where are we on alchemist? Am I not hearing you or what? Are you all able to hear me?
Yeah.
Okay, with respect to alchemist, where are we? Are we doing it or do you want me to assign that as homework for you?
Assign it.
Assign it, huh? Okay.
Assign it to someone.
Okay, so that way you will be good with algebra as well. In algebra, how meaning? Could you just give me a ballpark of where we are with alchemist, each of you? Have you done 50%, 10%, 20%? Many of the topics are in red like that. Hey Sham, how are you finding with your school? Is it matching or what are you doing?
It's really easy.
Your school is really easy?
Yeah.
That I see it. Are you following R.D. Sharma?
What? Oh,
What book are you following? Hmm?
Cambridge.
Oh, you're in Cambridge school, huh? Okay. 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 So it's an international school, huh?
Yeah.
So what book are you following?
And
You know R.D. Sharma book?
no,
Which grade are you in there?
grade 7.
7. Yeah, you should see the book by R.D. Sharma. It's really good. Today I was looking through grade 8, grade 9. It's really good. Okay. Yeah. Okay. How about the other? Hey, Dia, I had a request for you, ma. Please, you do it in a separate notebook, ma, your homework.
Okay.
Okay, so that only will help you to understand whether you're able to reproduce or not, right? Okay. Okay. Let's go back. What? I really wanted to go over a little bit of complex numbers today. Let's see. I'm going back and forth in the book now, right? No proper order, but that's okay, I feel. I really want to finish. And once we finish, I really want to understand how many of you want to continue AOPS geometry. I would like to get a heads up from you guys, meaning you want to go to school based geometry or continue with this class. That's something I want to understand as well. Does that make sense? Maybe next week, can I get it? Will you discuss with your parents and let me know?
Hi, Auntie.
Hi, how are you?
I'm good. How are you?
Good to see you. Hey, you did that, what is that, mini moo,
Yeah,
right?
mini you.
How well? You do look like you did great.
Yeah, there was like some 8th graders.
Yeah, I know, but looks like you did great. Good job.
Oh, thanks, Auntie.
Very proud. But what were the questions like you did not know?
There was like a question with logarithms.
Oh, that's okay. That's okay. See, basically, we will cover some bit of exponential and logarithm in this class as well.
Okay.
So that comes a little later, though. Okay, you have time as well. Okay, so let's.
Okay.
Um,
Auntie.
yeah, go ahead.
There in the algebra 1 competition, there's kids who took algebra 2 who just wanted to take algebra 1.
Which makes sense, right? Yeah, it depends on the regulations. Once you have these invitationals and all, anybody will join into anything. because those kids would have, see, by grade doesn't matter, right? At the end of it, which, see, I don't know what grade each of you belong to right now, if you ask me right off my head. So it's like that, right? That's what will happen even when you grow up, meaning from now on, that's what will happen, right? Anybody, see, you can compete with a ninth grader may be doing algebra 1. You can compete with the, maybe next year you can compete with a 10th grader who is doing geometry. We won't know what grade he is in, only that they do algebra 1 or geometry, right? So that's what will happen, but that's okay, don't worry about it.
Okay.
Okay, let's see.
I did.
Okay, how about this? Um, okay, okay, let's see where we are on this. On this, let me go to complex numbers a little later. Ashwin, how are you, Ashwin?
I'm fine.
Are you still getting
Are you
overwhelmed?
still getting overwhelmed? Huh?
Are you still getting
Are you
overwhelmed, or
still
are
getting
you?
overwhelmed? No, I finished.
Oh, you finished this week
Oh,
5
you
problem.
finished this week 5 problem? Yeah.
Did you understand? Do you have any
Did you
question? I
understand?
didn't
Do you have any
submit your.
question? Yeah.
I didn't see your
No.
homework.
I didn't see your homework. Really? I submitted it.
No, I graded everyone's.
No,
When
I
did you
graded
submit?
everyone's. When did you submit? Like just now.
Just.
Just.
How will I grade it? There's no way. I graded it an hour back. So how about this? Do you know the formula for this?
Is it a squared plus b squared plus 2ab?
Yep, this should be in your brain. You know how I got this? I think we did this already. A plus b times a plus b. So first a times a square, a times b, ab, then b times a plus b square. So this gives you a square plus 2ab plus b square. Every time you can't be doing this. You see, so this method of multiplication, right, two binomials, you are multiplying two binomials, right? So see, this is a monomial, this is a binomial. Monomial, when you say it's a monomial, this is a binomial, because see, this is called a term, this is called a term, this one is called a term. So when you have two terms, it's binomial. So what is this then? This is a trinomial. But here guys, very important thing, when will you call out something as a monomial? It can have coefficients accompanying. This is a variable, this is a coefficient accompanying the variable, coefficient accompanying the variable. Okay, it can have coefficients with the variables. However, the power of the variable should be positive integers. The power of the variable should be, I will say, whole numbers. The power of the variable should be whole numbers. What is the difference between positive integers and whole numbers? What is the difference? Those are the subtle things I really want you guys to know. What is the difference between positive integers and whole numbers?
Integers can be negative.
Yeah, what I wanted to ask you is positive integers and whole numbers. What is the difference?
Good ideas for stuff to
Hmm?
do. Good ideas for stuff to do.
Should I give you idea? What is the difference, guys? What is the difference between? Please don't Google now. Whether you know, it's fine. If you don't know, it's okay. We will discuss. What's the difference?
I think whole numbers include 0.
Yep. This includes 0, 1, 2,
0, 1,
1, 2.
Okay, but
Yeah.
does positive integers have 0 too? I don't
No,
know.
it doesn't. It doesn't.
Oh.
Positive.
Negative.
Yeah, or I can say non-negative. Non-negative or positive integers. So they don't include 0. Okay. So this one is quite heavy.
Non-negative includes 0, but positive doesn't.
Oh no, yeah. Okay, that is true too. Okay, guys, there is one subtle difference. Okay, let me highlight it here. If you say non-negative integers, right? This includes 0 because 0 is not negative. Whereas if I say positive integers, right, it does not include 0. You got it? There's a subtle difference between the two. Got it? Okay, so these are the things you need to know definitely. Okay, now we were discussing monomials, right? I didn't want to go from there. See, monomial means you can have these. You see, the power of this is always a whole number. It can be 0, 1, 2, 3, 4. Whereas is this a monomial? No, because this is 2 by a. It cannot have a power that is a negative integer. Got it? Okay, how about this? Is this a monomial?
No,
Why?
because the square root of k is equal to k to the power of 1 over 2.
Yep. So let's discuss that as well. I've never had that discussion in this class. Let's see. See, now if you take this is square root of k, right? How do you express it as a power? K power 1 by 2. Cube root of k, meaning whenever you have a radical and a number here, if you don't have a number, it is implicitly a 2. That is why you take it as square root. But a number is given, then it becomes k power of 1 by 3. Similarly, 1 by k is written as k power of minus 1. This we studied in pre-algebra. This also we studied, but now this is a review. Now, suppose if you have the fifth root of k square, how do you convert it to an exponent? These are just extra things that I want to discuss.
Is k to the power of 2 over 5?
Yep, k power of 2, then this becomes 1 by 5, right? So 2 by 5. Make sense, guys? How about this? K power of 4, 14th root. What will this become? K power of 4 is written, but then this fraction is by 14. You got it, guys? Okay. As we move up, it'll be very helpful. Okay, now that you know a plus b the whole square, this we have already discussed. I don't know why you have not by hearted it yet. How about a minus b the whole square? A minus b times a minus b. This way of multiplying a with these two, right? And then b with these two. This method is called FOIL. First terms. First you multiply the first terms. A minus b times a minus b. What are you doing? First you multiply the first terms. Then you multiply the outside terms. Right? Then what do? You multiply, let me write down what it is. A square minus ab, right? And then what do? You multiply the inner terms, minus ba. And then the last terms, plus b square. As a result, this becomes a square minus 2ab plus b square. Any questions, guys? We have already discussed this. I really want you to memorize this. Can I move on? What about a plus b times a minus b? Every time you cannot be doing this.
A squared minus b squared.
Yep, a squared minus ab plus ba minus b square. This and this get cancelled. So, a plus b times a minus b will always become a square minus b square. These three, you should tell it in sleep. Can I move on? Can I move on? Okay. I know we covered sums and roots. This extension I did not cover. Okay, let's see. It's hard. Okay. So I told you about coefficients. Okay. Can I move on? The three formula you should know whatsoever. Then only I can move ahead as well. Okay, now let's say you want to expand this. What will happen if you expand this? You know this can be written as this times this, correct? The power is 2 and 1, making it 3, right? But you know the expansion of this already, x square plus y square plus 2ab, right? Now you can multiply using this method, x cube plus xy square plus 2xy, that becomes 2x square y plus, then what happens? I'll start multiplying with the y. Y x square plus y cube plus 2xy square. Now what can I combine? I can combine only like terms, right? X cube and y cube are going to stay. Okay, so I've taken y cube are going to stay. I've taken care of them. Now can I merge this with this? Yes, both are x square y. So 3x square y. Then I can merge these two plus 3y square x. So when it comes to multiplying this, as I said, right, monomial, we have introduced you to monomial binomials, right? So basically, if I say this very sophisticatedly they call squares of binomials. Squares of binomials. Any questions? What is this then? Cubes of binomials. Make sense? Okay, how about this? I'm going to write it down. A plus b the whole square, as I said, is a square plus b square plus 2ab. You're going to memorize this. There's no other go. A minus b the whole square equal to a square plus b square minus 2ab. Okay, a plus b the whole cube will be equal to a cube plus b cube plus 3a square b plus 3b square a. Okay, I don't want you to give it like this. Same, I am going to rewrite it in a different way. A cube plus 3a square b plus 3b square a plus b cube. A minus b the whole cube, that way you don't get confused. A cube, alternatively minuses will come. Make sense? Okay. I also told you this is a very special one. A square minus b square will be equal to a plus b times a minus b. This is so important everywhere. You know, sometimes they may ask you 2014 square minus 2012 square. It's so easy to do. This follows this formula. Do you see it? So what happens? A plus b, 4026. Add them together. Subtract them together. Multiply both, meaning multiply both in the sense you are going to double it. That's all, right? So it becomes 8052. Make sense? This is a very famous one. It's applicable in so many scenarios. It's very easy to do big calculations using this one. Can I go ahead? Can I go ahead?
Yeah.
Okay. How about this? Okay. Now, suppose if you are given a quadratic function. Suppose you are given a quadratic function. You are given a quadratic function like this. How can you say that this is a square function or not? Meaning, how can you say that this can be written as a square of a binomial? How can you say that? When you think about it, this is a square term, this is a square term. That gives you an indication that it might be a square of a binomial, in the sense, see here, suppose if I take this as a, if I take this as b, and if I take this as a square, b square is in here, is this 2ab? I can check. No. So this can't be written as a square of a binomial. Whereas if you're given like this, can this be written as a square of a binomial? Yes, this is a square term, this is a square term. True. What is x is a, 2 is b, so 2 times 2ab is multiplying 2 with all of these. Yes, that is in here. So I can say this is of the format a square plus 2ab plus b square. So my binomial square would be x plus 2 the whole square. Any questions? You have to first identify the first and the last term. If they are squares, then go ahead and check whether this is 2ab. Then you can put it into the square of a binomial format. How about this? 16z squared minus 24z minus 9. Is this a square of a binomial? Immediately seeing that signs, you can say, is this a square of a binomial? Huh?
No.
No. Why?
Because 24 wouldn't be 2AB because 16.
Nice, nice. But the
Like,
sign should be positive for both the
yeah.
squares as well. Great. Okay, how about this? Um, y square plus 14y plus 25. Both are squares. Plus is there. Is that a square of a binomial?
No.
No,
No. Why?
because when you none of the factors of 25 add up to 14.
I agree. So 2ab means it has to be 2y5. It should have been 10y. So this is incorrect. Okay. Now let's see this one. 14. How about this? 4y square minus 28yz plus 49z square. Can this be written as a square of a binomial? Guys, if Ashwik, you're not on the video, Ashwik, I really want everybody to be on the video. You know, the other day what happened? Did I tell you the story? There was somebody joining into this, into one of the classes, posting. Yeah, please go ahead with this. 4y square minus 28yz plus 49z square.
It's not because one of the sign is negative.
But a minus b the whole square formula is a square minus 2ab plus b square, right? Only thing minus cannot be here. But yeah, the squares cannot be negative, right?
Yeah.
So is this a square? Yes. If you think about it, what is the square root of this? 2y. What is the square root of y? 7z. Now I'm going. Huh? 7 is 14, 47, 28 is yz is here. So is it not a square of the binomial? The binomial is 2y. See, 2y minus is here, right? Minus 7z the whole square. That's the square. You got it?
Yeah.
Everybody got it?
Yeah.
Okay, good. Okay, how about this? Z squared minus 8z plus 16. Can I write it as a square of a binomial? This one is easier. Go ahead.
Yeah.
Yes. So what is the binomial?
Miss Priya, is that my answer?
Okay. Let's see. Yeah, that's right. Some of you are not answering. I don't know whether you're not understanding or not. The square root of this is this, square root of this is this. Clearly 2 times this times this 8z is here. But there is a minus. So my binomial is going to contain a minus operation in between. This minus this the whole square. Sham, are you following Sham?
Yeah.
Anish, are you following Anish?
Yeah.
Okay, let's see this one. I really want you guys to tell me whether you got it or not. Okay, how about this? How about 6? I'm making myself. Okay, how about this? Can you square this in your head? Can you square this in your head based on what we learned? Can I give you a clue? Make it into a binomial. Can we square this in the head?
Andy,
Yeah.
I saw it was like 70 squared plus 70 plus 71 or something.
Yeah, but you can write it as 70 plus 1 the whole square. This you can do it mentally. What is 70 square?
4,900.
4,900 plus 1, 4,901, correct? Right? Don't worry about the 1 now. 4,900 you have. 2 times A times B is what? You're going to add 140. 4,900 plus 140 is what? 5,101. That's the answer. You got it?
Yeah.
So, this is a very easy way to do things, to do fast math. 5,041 or 5,140, Amma? I thought 5,140, right? 4,900.
5,041.
Yeah.
5,041. Sorry, correct. Not 5,041. Correct. Can I move on? Okay, now let's see this one. How about 99 square? You can still express it as a binomial. How?
100 minus 1
The whole square.
squared.
So again, you follow this 1, 2, 3, 4 plus 1 minus 200, right? So now 10,000 minus 200 is what? Can I write it like this? I'm sorry, plus 1, right? Then, 8,800. Can I say that? And then
Would it be 9,801?
9,000 why? Yeah,
Yep.
9,801. Correct. 803 why?
No, it'll be 801.
801, right, Sham? Sham,
Yeah.
will it be 9,801?
Yeah.
Okay, good. Okay, let's see this one. So like this you can make use to make magic, literally. How about this? 2006 2005 square minus 2 times 2006 2005 times 2006 2003 plus 2006 2003 the whole square. What is this, guys? Do it mentally. How to do this mentally? What is the answer? You can say quickly. It's not going to take time, honestly. Anish, why don't you answer? Do you know the answer?
No.
Is it? Think about it, guys. It's in the same format that we discussed, right? Yeah, what is that, Ritisha? You took the time to type this long, but you could have said the answer in a single number. What's the answer? Ritisha, what is the answer, Ritisha? Subtract it.
Hold on.
You got
Is
it?
it 4?
Yes. 4. Because this
2
is
squared.
A
I did
square.
A minus B whole squared
Yep.
equals.
A, this is A, this is B. Subtract both 2. A minus B, the whole square, right? A minus B is this minus this is 2. 2 square is 4. See how easy things are, provided you apply proper things. Anish, did you understand how? Anish?
Yeah, I understand.
Oh, okay, good. Okay, how about this? You're going to try this one. You're going to try this one. I'm going to leave it to you. Okay? Can you try this one? What is the value of this? I'll leave it to you, but I want the fraction.
Miss Priya, I sent my answer.
Yes, ma. Ah, Ritisha, really? I don't think so, ma. How did you get that? Uh, I don't think so, Ritisha. It's a complicated fraction, I thought.
I could show you how I did it afterward.
Yeah, you can show. Yeah, let's discuss now. Others are working. Go ahead.
Basically, I did this. So I took the square root of it's square root of 6/7, right? So then if you square that, that's just 6/7. So the first term would be 6/7 plus 1/6/7, right?
But I can't take this as 6 over 7, right, ma?
No,
Yeah,
no,
but
I'm saying once you square it.
Yeah, once I
I,
square it, okay.
it could
so
be.
it'll be like this. Okay, I can't do this right. Yeah.
Yeah. 6 over 7, and then
Plus 7/6.
how? Okay, 7 over 6, okay. And then
Because 1/√6/7, basically once you square that, that's just 1/6/7, which
okay,
equals 7/6. So
perfect. Okay, so this one is 7 over 6, okay.
then when you add those two, the common denominator is 42, right?
How? Oh, this can't be split like this, right?
All right. Okay. Now
That's
I
a
get my
very
mistake.
common mistake you guys do. Don't do that. This can't be split like this. You have something here plus 2ab, right?
Yeah.
So
Hold
that
on.
yeah. Diya, I'm not getting answers. Vidyut, are you getting it?
I got like a weird answer.
What is it?
I got 169 over 49 over 12 over 7.
And I did it a little differently.
That is
Wait, give me a second to simplify that.
Because I got 6 over 7 minus 2 square root 6 by 7 divided by x plus 1 by x whole squared.
okay. I'll wait for everybody to answer. Okay. Let's see what you all get.
I said my answer.
Yeah, ma.
I said my answer.
Hey, Vidyut, your
Hey,
cancel.
with you.
The denominator seems incorrect. Johan, it's not. Oh. Johan, did you answer as a mixed number?
Yeah.
I think that's. I think that's right. Yeah. Yeah. There is an extra 2 Vidyut in your denominator. Oh, 2 1 by 42. Sham, is that right? 2 1 by 42. I thought it's 4 1 by 42, right? 81 by 20. Illi diya. No diya. Yo, Ritisha, no. X plus 1 by x the whole square is x square a square plus b square plus 2 times x times 1 by x. So x and x get cancelled. X square plus 1 by x square plus 2. What is x square? If x is
Okay.
this, x square is 6 by 7. Okay. Now if
Okay.
x square is
Yeah. No, I got it. I'll
1 by
just.
x square is 7 by 6. Now I can add 6 by 7, 7 by 6 plus 2. So if you do this, 42 will be my denominator. 36 plus 42 plus 42 times 2, 84. So that gives you 84, 42, 36. I'm going to add 162 by 42. I'm getting.
Wait.
Is it right?
Right? I
Oh,
got
stop.
169.
Oh, I got 169 over. I got 169 over 40.
Yeah, me too.
169. I'm not getting. Why? Where am
I'm not
I?
very well.
I'll check.
I'll check.
84. Here, oh, this is 49. So that's 169.
So that's 169
Yeah.
by
69. Ashvik, how did you do? You wanted to explain. I think you got cut off.
No, I couldn't do it. I did it bad.
No, your answer was right, right? Your answer was right. Why?
Well, I got 169 over 42.
Yeah, that's right. But why? How did you do? You said something and you just.
No, that was like that was back then. So what I did is like so 1 over x was 1 square root 6 by 7. So then I made that square root 7 by 6.
Okay, square root 7 by 6. Okay.
And so then x plus 1 by x would be square root 6 by 7 plus square root 7 by 6.
Uh-huh.
And then I did a equals to square root 6 by 7, and b would be square root 7 by 6.
Okay, that's also good only. Why? That's also good only. Why? That's right.
Yeah, so then I did a
Yeah,
square
yeah,
and
yeah, that's correct. That's also correct. I agree. Perfectly correct. Vishnuram, are you following?
Yeah, I got the answer like this
How
now.
about this 204 the whole square? What is a quick answer for that one? Mentally you can do. You don't need a pencil. You don't need a pencil at all.
I sent my answer. The first answer I think is wrong, so
I'll check. That's right, Vidyut. Did you do it mentally, Vidyut?
no, I used a paper and pen.
Anish, correct. Ashik, correct. Anish, did you use a paper? Ashik, did you use a paper? Without using a paper, try, guys. You will be able to. Circus missions. This book covers a whole lot deeper. Did you get it? Johan, did you get it? Vishnuram, you made an addition mistake, Vishnuram. Isha, correct. Diya, correct. Ashwin, correct. Sham, will the answer be so small? Sham, I'm waiting for your answer. Johan, correct. $200 plus 4, right? Yep, that's right. So the answer was 200 square, 200 a square plus b square, right? So 400, another 20, then you have to add a 16. But apart from that, what you need to add? 1600 you need to add. So this becomes 1600, but 16 will get added, 41616. Can we move on?
Why do you add the 1/6? Like,
Because a square plus b square 400 followed by 4 followed by 4 zeros, right? Then 16, then 2ab. 2ab is what? 800 times 2. This is 2a.
oh yeah, I forgot about the 2AB.
Yeah. That's natural. Initially, when you learn it, always is the case. Okay. Now, for these polynomials, right? We did discuss this, okay? See here, x plus y power 0 is a 1, correct? X plus y power 1 is what? See what will be the coefficients? X and y, right? It's a binomial. Whatever I'm using is a binomial. X plus y the whole square is what? This is equal to x square plus 2 xy plus y square, right? So that is 1, 2, 1. See the pattern that's evolving. X plus y the whole cube is what? X cube plus 3 x square y. The power of x is reducing, power of y is increasing, correct? 3xy square plus y cube. So can I write it as 1, 3, 3, 1? Now if I continue the pattern, 1, 4, 6, 4, 1. So x plus y the whole power of 4, how do I expand it? See this and you can expand. X power of 4 plus, what happens here? I write the coefficient from this. and then I decrease the power of x, increase the power of y. Then I copy the next coefficient, decrease the power of x, increase the power of y. Make sense? And then I copy the next coefficient, decrease the power of x, increase the power of y, and then last I copy the coefficient, decrease the x power 0 is just 1. So y power of, see, this is how you expand. You know what is this called? I can keep on expanding. What I am doing here, the added value of this, do you see that? What is this called? Has anyone seen this? What is this called?
A triangle.
Pascal's triangle. Okay, the mathematician Pascal came up with this. So it's called Pascal's triangle. Okay, so whenever you have a binomial, so now x plus y power n, I can expand it very nicely, right? When you think about this, there are so many magic behind this Pascal's triangle. I'll tell you one. Okay, this is 2 power of 0. This is 2 power of 1. Sum of them. This is 2 power of 2, 3, 4, right? 2 power of 2. This is 3, 6, 7, 8. 2 power of 3. The sum of this is 6, 10, 14, 15, 16 is 2 power of 4. This is 2 power of 5. Do you see, guys? There's so much of magic in this Pascal's triangle. Does that make sense? So basically what I took up 1, 1, 1, 1, 2, 1. I just added these two, 1, 3, 3, 1, 1, 4, 6, 4, 1. So this is considered as row 0 of the Pascal's triangle. So that is the sum of all on that row is 2 power of 0. This is row 1. Sum of the numbers of the row, the coefficients are 2 power of 1. This is row 2. The sum of the coefficients is 2 power of 2. It goes on like that. And if I just want to, let's say if I just want to expand x plus y power of 2, you can see the x plus y power of 2 is what I want, right? So you go to row 2. What do? I take this. I have the maximum power of x here, x square, right? 1 is the coefficient. Then 2 is your coefficient. Reduce the power of x. This was y power of 0. That was 1. Anything power 0 is 1. So here you increase it and then you increase y, decrease x, but copy this coefficient. So this becomes x square. This goes plus 2xy plus y square. Did you guys get it?
What about row 5?
Row 5 you can go on if you want to. 5, 1. So this is 2 power of 3, 2 power of 4, 2 power of 5. The sum of this is what? 32, right? 20.
Yeah.
Yeah.
That's my question. So like that's
Priya?
like you said that the sum of number 4, 3, and 2 is like if you add them and then square it, then like not square root it, then you'll get power of 4, but like it's not working there.
Which one, ma? Which one? Come again?
For the 1, 5 for the fifth one, it's 32. But if you square root that, it won't be 5.
No, I did not ask you to square root or anything. I said the sum of the coefficients of each row will be equal to 2 power of the power is that row number. That's what I said. I didn't ask you to square root it, right? The sum of the coefficients, right? If I say x plus y power 4, right, when you expand it, the sum of the coefficients will be equal to 2 power of 4.
Yeah.
Make
Okay.
sense?
Yeah.
Okay. So this is called binomial theorem. I'm sorry, Pascal's triangle, and coming with a formula for this one. That this is a binomial, right? This is called the binomial theorem. Make sense? And each of these numbers also has a pattern. For that you need to know combinatorics. You guys still are yet to be introduced to it. So each of this, when you think about it, right, this one is row 3, so 3c0, this is 3c1, this is 3c2. For that you need to know combinatorics. We'll do that later. Okay, we'll do it in geometry. You don't know that, so I have not gotten you there. Okay, but Pascal's triangle does magic with combinatorics. Make sense? Can we move on? How would this? This is interesting, guys. Is this a polynomial? Is this a square of a binomial? It is a polynomial for sure. Polynomial means many terms together. Each one is a term, right? Whatever is separated by pluses and minuses are terms. Each is a monomial. When you think about it, the power is greater than 0 or greater. So each one is good. It has coefficients. It is a trinomial. 3 terms are there, so it's a trinomial. But is this trinomial a square of a binomial? Is this a square? Whenever you have to add them, right, t power of 4 cannot be added with a term that has t squared. Only like terms can be added together. So none of this can be combined. This has t power of 0, the rightmost, t power of 2, t power of 4, nothing can be combined. But is this a square of a binomial?
Yes.
What is that binomial?
It would be um
Let's do it. Let's do it.
because
So,
you would multiply t squared over 9 by 36 and it would be 4. Oh wait.
Johan, your guess is correct,
Yeah.
but let's think out loud. I'll think with you. Go ahead.
So
Yes,
square root
please,
of
please, go ahead.
36 is 6 and you multiply that by 9. You multiply that by t squared over 9, which would be 6t squared over 9, and yeah, so, and then you multiply that by 2, but
So
yeah,
what should be A C? This basic.
A
Go ahead.
A would be t squared over 3
The
and
square
B
root of this is A. What is the square root? T
t
power of,
squared over 3
t squared.
yep, t square over 3. B is what?
plus 36. I mean plus 6, plus 6 I meant.
Root of 36. Square root of the last two terms, right? So plus 6. Again, I want to verify this, right? So 2 times A times B, I'm going to multiply and see. 2 times t square by 3 times 6. What is it? 2, 4t square. Yes, I perfectly have it. So it is a square of this binomial. Make sense? See, these things, if you already have a hang of it before they start in Algebra 1 in your school, you will enjoy the class. Okay, now let's see this one. What is this? It's a tricky one. I did not discuss this with you. I always discussed squares of binomials I did, but I did not discuss, see, this is squares of binomials. Okay, this is what I discussed. Always I discuss these things here in this class, right? What I did not discuss in depth was, I said there was one formula that is so useful, is the difference of squares. This formula is called difference of squares.
Can I go to the bathroom?
Yeah, you can. Please come back quickly. This one is squares of binomials. Understand the difference. Why do we call that? This is difference of squares. Now tell me, what is this? Which format are you matching this up? Recognizing pattern is a very good skill. What pattern does it match up to?
Difference of squares.
Yes. So what is a square?
A squared is
Z squared.
Z square. Correct. What is, see, this is basically some square minus square. So this is of this format. So basically this is a square, this is b square, and I can write it out as what?
Z squared plus 1 times Z squared
Minus 1.
minus 1.
That's it. You got it? So this is a plus b times a minus b. Make sense? Ashwin, are you with me? Shyam, are you with me?
Yes.
Yeah.
Anish, we did discuss this. Were you here? Did you see?
I went to the bathroom.
Yeah. So difference of square can be written as a plus b, a minus b. There is a difference of square. So I found out if this is z power of 4 is a squared, what is a? A is z squared. B square is 1, so b is 1. So a, b. I wrote it out as a plus b, a minus b. Make sense?
Yes.
These are very interesting, guys. If you
Mhm.
let's see this one. Hmm. Let's see this one. How about this? This is a little tricky. I don't know whether a quadratic is the square of a binomial. Okay, let's see. Yeah, this is a tricky one. Let's see. I don't have the answer, guys. I need to work it out and see. I don't know the answer, but looks like it's a hard problem. Let's see. Is this a square of a binomial? I don't know, honestly. I'll work out with you. Oh, wow. Okay, that's a complicated one. Let's see how does it.
Miss Priya has sent my answer.
I'll check, ma'am. Oh, wow. That was so good, Ritisha. Correct. You made it so easy. Hmm? Any clue? You can take something common. You can take something out as common.
Like,
You
what
can.
do I? What's the question?
I just want you to express as a square of a binomial. What do they want to do? Yeah, we'll do one more. Yeah, 3 and 4. I hope you all remember using the quadratic formula. We went over quadratic formula, correct, guys?
Yes.
Okay. Next week I'll do sum and difference of cube. And I don't know, Simon's favorite factoring trick is a part of competitive math. Do we want to do? I don't know. Let's see. Did you all get it? I'm waiting for answers. You can take something common out. Then express it as a square binomial. I'm waiting. If you're stuck, you can ask. I'll help. Hey, one request, guys. See whether the classroom recording is being posted in the stream. Classroom, Google Classroom stream. If it is not getting posted, please, one of you, keep me posted. I'm trying to bring the class recording to your Google Classroom. So keep me posted. Oh, that's nice. Johan, that's correct. Did you take something out as common? You can take 2 as common, right? Shall we try? Yeah, Johan, that's correct. But I didn't get the answer from some of you. I'm waiting. Should I move on? Sham, that's correct. Ashwin, that's correct. When you take 2 as common here, this becomes y square minus 14y plus 49. This is a square, this is a square.
That's an answer.
Y minus 7, the whole square. That's all. Vishnu Ram, are you following? Diya correct, Ma Vidyut correct.
Yeah.
Okay. Ashwik, did you get it? How about this? Sometimes things are not as hard as we see. I don't know the answer for this. Okay, we'll work it out together. Let's see. Okay. Now find x when y will be equal to 2 by 3. Yeah, many a time when you have square roots, right, it's sometimes easy to square them and find answers. You want to try or you want me to try? Let me know. Well, there's a lot. Nice, Vishnuram. Are you trying or you want me to try, guys? I think there are multiple ways to solve. Let me try my way, you try your way. You can do whatever you want actually.
I'm kind of confused.
Yeah, me too.
When you think about it, this is like a minus b, a plus b. Do you see it?
Mm.
Do you see it?
Yeah, I see it.
Yeah, I think that is really helpful to see that there. I am thinking, yeah. But if I multiply both, what happens? A plus b, a minus b. So that would be a square minus b square. B square is very easy actually. So what happens here? Everything is getting cancelled. Oh, see? I'm getting it as 3 by 2. Is that right? I don't know. Yeah, that's right. Did you guys get it?
I did it differently.
How did you do? Tell me. There are so many ways to do this one. Go ahead.
Well, I did So basically, I had to multiply the first equation by the second equation to get rid of the square root term. And then after I did that, I got 5xy equals to 5, and then I got xy equals to 1. And since y equals to 2 by 3, I did 2 by 3 x equals to 1, and so x would be 3 by 2.
Perfect. That makes sense too. Ashwin, did you understand?
Yeah, auntie.
Diya?
I understand.
Okay. Vidyut, did you get it?
Yeah, I understood.
Okay, can I stop here and ask you to do? Okay, coming to Alchemist, right? 11.1 and 11.2 exercises, let's do. Okay, before you all log off, right? Let's check into the status of Alchemist. Let me show my screen. You don't have to, none of you need to show your screen, okay? Let me go ahead and show my screen. Let me know what is feasible from your end. I will sign into whatever my ID is and you can check. But you are going to guide me what do you want to do as homework, meaning we really want to move on with that, meaning we really want to move ahead with that. So I'm asking you what is viable. Oh, where is that Alchemist? Tell me what is, change focus. Now we'll go to algebra. What do you want to do? Which one do you want to do? Guys, you decide and tell. I'm okay, but let's do what is viable. I don't want to overload, but at the same time we want to keep moving with a little bit of this. We are here, meaning you know the
What squares of a binomial?
yeah, here difference of squares. This is what I've covered. But for that matter, we have also covered this functions a little later. We'll see. We don't need to go there yet. And also see quadratic optimization is the linear programming. No. Quadratic optimization is not the linear program. Linear optimization will be there. Where is optimization? Oh, okay. See that one, the optimization was not enough. That's why I gave you the assignment. So which one do you want to do? Quick, guys. Which one do you want to do?
Squares of binomial.
Okay, let's do this one. Okay, let's go ahead and do
Square binomial.
square of a binomial. Okay, then you do both. Okay, only 2 this week, huh? I'm okay, guys. Say yes, no. That's enough for me.
Yeah.
Okay, then we'll do only 2. Square of a binomial, difference of square we'll do. Okay. Exercise, book exercise 11.1 and 11.2. Make sense? Exactly what we have covered in class. Can I stop here?
Yeah.
Okay. Okay, guys. Then we'll see you all next week. Any questions? Stay.
Bye, auntie.
Bye, Auntie.
Bye, ma.
Thank you.
Bye. Have a nice week ahead, guys.